behavior-driven development with Gherkin for Python testing. And my name is Robson, Nasciemento de Sousa. I have a quick introduction about myself here. So I am 22 years old. I am located in Santa Inês, Maranhão, Brazil. It's a very small city here in a not so known state in Brazil. So you probably never heard of that, but that's where I live. My favorite hobby is playing games with my friends. I love playing some online games. I think the game that I've been playing the most with my friends recently is Valorant. I even have some gaming pals here. So yeah, very nice. And I also love learning about software, and that's like overall about any languages, any software technique. I really love learning about software in general. So for my studies, I am graduating in electronics at a technician level, and I'm currently studying computer engineering, and that's my graduation. If everything works out, I'll be finished by the middle of this year. And I am working as a functional safety engineer at Ford, and I have been there for a little over 2 years. Before that, I was a researcher. It's a spot similar to being an intern. So yeah, this is my first job. And before that, I have a lot of experience in working with projects in university and high school. And yeah, that's where my programming software development background comes from. And some of my awards that I have 10 medals in total on mathematics Olympiads. And this goes like way back from when I was in high school. And I think the greatest one that I have is this golden medal on the AIMO, that's Asian International Mathematics Olympiad. And it was in 2018. It was in Thailand. It was a very nice competition. And through what I'm aware of, I believe I'm one of the 3 only Brazilian that have gained a golden medal in this competition. So yeah, it's very nice. And I participated in an exchange program in Japan in 2019, and I really love like Japan culture, and I really love the anime, so it was a very nice experience. And I started participating in programming marathons some time ago, and I got second place last year, and I got third place 2 years ago, and I was able to participate into this regional SBC programming, and I was able to go into the national level as well. It was very nice. And recently, last year actually, I also participated in these robotics Olympiad in Greece. Yeah, so very nice. I have been participating in a lot of competitions. I really not like the whole gist of competitions. It's where I'm really challenging. So yeah, very nice. You can find me on LinkedIn and on GitHub. I think we can provide you the links after the presentation is done. Okay, so let's get started. What is behavior-driven development? I'm not sure if you have ever heard of this term before. We usually also refer to this as BDD, which is the abbreviation for this acronym. But to get started on this, I first wanted to introduce a little about what is software engineering in general. And being like on the very high level, I would say that software engineering is really about taking this step from having the user desired functionalities. So any sort of functionality the user wants, any sort of feature the user is looking for in an application, in a software piece, and getting from that idea into the working software application, into this final product. And there are a few other things in the middle of this process, but yeah, that's basically getting to this development process. And we usually refer to these functionalities as experiences, or you could also have heard about user stories. We'll be talking about user stories here. And it's basically defined like a small increment of software, a small piece of software, like some logic that we are going to implement that is going to bring some value to the user, some experience to the user. So it could be basically anything. If we're writing an application for, let's say, some marketplace, we could make it so that one of the features that we're developing is adding a product into your shopping cart, for example. And yes, so it's like some of those things. And we usually take this approach for developing software because, in engineering, we are really trying to break these big problems into small programs. And to do that, we define like some small increments in functionality, some small user experiences that we want to deliver, and we focus our development around those. And there are a few other things to software engineer as well. We are really worried about all of those steps here. So design the software, develop the software, test the software, and maintain the software. So yeah, there is a lot to it. And I think a few of you might have some experience with software engineering already, but I just wanted to give a quick background to make sure everyone is on the same page. Okay, so how is software development process, how does it look like? So we have a few different processes, and this is something that really some big companies are trying to apply some new processes to make the development more fast and more responsive. We can make changes, we can deliver the value faster, and this is kind of a big thing. And for that, we have a few different types of processes for software development. This is what a traditional software development process might look like. We start, as I said, with the user stories, which is the small piece of functionality that we want to deliver to the user. And we write requirements for those, we develop the code, we create test cases, and then we run and approve tests. I think this is kind of the usual process. And if you are, I guess, learning about software, if getting started with this whole software development career, you might really be on focusing more on this middle part here, which is just developing code. You just have an idea, yeah, I'm going to develop this, and you have no requirements, you have no tests, and I think this is something that there's a lot of value in doing all of these things around the code. It's not really about just writing code. It's about making sure your code makes sense, you're delivering what you want, and it is working. It's not break. It can also maintain the code. You can also bring new functionality into it. And I think test cases, this test step in running approved tests is going to be a big part of this presentation. I'm going to talk a little more about that when we get into the coding part, because I think this is going to be a nice one. Okay, this is another type of process that is kind of an upgrade from the previous process. It is the test-driven development. For this one, we usually call it TDD, which is the abbreviation. And here we try to make things in an increment in this cycle process, which is we start by having the unit testing. The whole idea of this process is having tests first. The first thing you'll do is you write a test, and then you develop the code around that test. So to do that, you go into this cycle process here. You start with the unit testing. So the test that you write on Python, I can show it later how it looks like, but it's the test. And you run those tests and watch them fail. And as you can see here, I have highlighted fail because this is a big thing. You need to make sure that your test is failing, because if it is failing, that means your test is really checking the value that you want to deliver. And if you see it's failing, that means that you can go to the next step, which is actually developing the code. So you just develop like the smallest amount of code just to pass that test. So you go into this this second step in which the test was failing, into another step in which the test is not. Don't know what refactor means. It's basically your code is working, you're not changing the behavior, you're just rewriting it to make it more simpler or more readable, or just make some overall improvements. And you do things in this cycle in which you create a test, you run and watch it fail, and then you develop the code for this test, and then a refactor. And you just repeat this in a cycle. And I think one of the key components for this approach is that we focus on the how. We focus on how my piece of software, how my application is working. We are really testing how it is functioning. And we are using unit tests here. And unit tests are, like, overall, they are very tied to the code that you're writing. So it is very close to the implementation level. It's very technical, and there might be some issues that are kind of what the behavior-driven development process try to solve. And I'm going to talk a little more about that as we go. But that's one of the characteristics of TDD. It's very technical. It's very software-based. So the tests are all very dependent on the software we're developing. And one of the big things here that is kind of the biggest challenge in TDD is writing good tests, because tests are the key player here. And okay, so now let's go to BDD, to actually behavior-driven development. So to explain this, BDD, I was looking through some videos yesterday, and I think it's like a really tricky thing to understand. I don't have a complete grasp on it yet, so I'm just going to try to give you an overview of what I understand for BDD. And to do that, I just wanted to first try to change the vision that we have about software development before we actually get into what BDD is going to do. So the first thing is if you are writing software, if you're writing an application and you want to apply BDD process, the first thing you need to do is forget about the code. Forget about what you're developing, forget about how you are going to develop it. You are really going to be focusing on the what you want to deliver. What is the piece of functionality that you want to deliver, and what is the value that it is providing. And that's kind of what I'm trying to capture here on this image. So you should really be focusing on this left side instead of this right side. So you should focus on what your software does instead of how your software works. You should focus on what behavior the user expects instead of how the technical details are defined. And you should focus on what the problem you want to solve is instead of how your solution is implemented. So that's the key thing about BDD. We want to focus on the value that we are delivering. We want to focus on this user story that we defined as I showed before. We want to focus on this value that we're delivering to the user. That's the big thing on BDD. And it is kind of an expansion of TDD. One of the main things that we do here is try to solve some of the issues that TDD have. Let me see if there's something else. Yeah, another key component of BDD is also that it tries to break the barrier that we have between the team members. There are the technical team members and the non-technical team members. And maybe you're not that familiar with this approach, but when you get into an agile team, an agile development team, you have like many roles, many people, and the team is composed by many roles. And not everyone is going to be like that close to software development. So they might not understand how, let's say, how you're developing the software, what are the technical details of that. And BDD tries to break the barrier of communication between the technical and the non-technical team members. And yeah, that's basically it. And this is kind of how the process would look like. It's very similar to DD, and actually it kind of incorporates DD in it. So we start on the user stories. As I said, we are first defining this value that we're delivering. We're defining this functionality that we want to deliver. When that's defined, we create scenarios. That's one specific term that we have in BDD. We're defining scenarios, and scenarios are basically just executable specifications. What is that? You might be asking. One of the things that BDD try to create is the specifications. By specification, you could think about having requirements for your code. You could think about having tests to your code. These specifications, they need to be executable. That means you can run your requirements against your code. You can run your tests against your code. That's one of the big things. But we are talking about scenarios because it's kind of a little different from just requirements or just tests. It's kind of something new. And on the other processes, we really go from user story to requirements or from user stories to tests. In this case, we're going from user stories to scenarios. And in theory, will be done by the whole team. So even like technical and non-technical people will be integrated into this process. When that's done, we will be creating and another thing is when we are developing scenarios, we really need to have the focus on testing. The scenarios needs to be testable. So this is one of the things that need to be kept in mind when developing scenarios. After the scenarios are defined, we will be creating the step definitions. I'm going to show you in details what step definitions are on the next when you get into the code. And that's basically you could think about translating the specification into code. How is that going to be working? So basically, with the BDD approach, we will be defining the scenarios, and the scenarios, as I said before, they need to be executable. And to do that, we need to create the step definitions in which they are going to read all scenarios. And each scenario is going to be composed of a lot of steps, and I'm going to show that as well. But it is going to be composed of steps. And what you need to do is you use step definitions to define which the steps are going to be doing in your code, in your application. And these scenarios here, I just wanted to talk a little more about this. So they are meant to be like very high level. You are really not touching the implementation, or really not touching the how of the development process. You are focusing on the what. So we could say, for example, that one of the steps that we could have, one of the scenarios, is testing creating a chessboard. And I'm going to show you how that looks like. But let's say I'm creating a chessboard and I know the dimensions should be 8 by 8. How can I do that? The scenario itself is just going to be this very conceptual thing. It's just going to say, yeah, I need a board. The board needs to have 8 by 8 dimensions. The step definition is going to be translating that into code. So it's going to be taking care of, okay, let's say that my solution is I'm going to be creating a matrix of size 8 by 8. And when I want to create this empty board 8 by 8, I need to create that matrix. This is what the step definition is going to be doing. It is going to be taking that high-level scenario into actual code. And when this step is finished, we basically have tests. It's basically just tests. We can run the scenarios as tests in our code. And when that's done, we can basically take the usual TDD process. So we have tests after the scenario is finished, and we drive the software development process from the specification, from this executable specification. So again, we just have tests. We can just use TDD process to develop the code. And we can actually also use any process. We just have we have the tests, and we can run those tests by the end of the traditional process as well, for example. So there are multiple ways of developing the code once this step is finished. Okay, so let's talk about Gherkin now. This is the Gherkin format, and it is a standard defined by Cucumber. And this is one of the tools that we have for the BDD process. I just want to be clear that most examples that you might find of BDD being employed are going to be using Gherkin, but they are not really tied together. You can develop a BDD process, a behavior-driven development process, with any sort of tools. Gherkin is just one of those tools that you can use. So there are a few other different tools that you can use as well. But I'm going to be focusing on Gherkin for this presentation. And what does Gherkin look like? So the Gherkin format is going to be looking like this. You are going to have a .feature file. This is going to be the main file in which you're going to be creating your scenarios. And here you can have as many scenarios as you want inside of a feature file. I'm going to show you examples of that very soon. But you're going to have scenarios. And for each scenario, the scenarios are going to be composed of steps. And each step is basically one action that you take on the testing process. So again, I was talking about the example in which I have an empty chessboard, and I can, let's say, start a test by doing that, by creating an empty chessboard. So the first step in this case could be creating that chessboard. And that's how the Gherkin files are arranged. And the standard, it tries to have an approach of making the scenarios be very human readable. So it's supposed to be like a very simple language, all written in very simple English. And anyone reading the scenario should be able to understand what's happening here. That's one of the key things on Gherkin and on BDD overall. And the Gherkin format is going to be using those keywords to define that. You have the keyword given, you have the keyword when, and you have the keyword then. There are also extra keywords, and I think the examples are going to show that better. But you can use this structure to define a test based on these conditions here. So you are going to have let's say that we are running tests on this chessboard. And we can write a test by specifying how that board looks on the beginning. So we have this initial stage, and I could say that I'm adding pieces, I'm adding like the standard piece arrangement for a chess game. And that's defining how the board or how the system looks like on the beginning. This is kind of preconditions for the testing. And once those preconditions are set, I can add a trigger, and that's defined by the when keyword. So I'm going to take an action, I'm going to interact with the system somehow, and I'm going to take specific actions. And once those specific actions are done, my application should respond accordingly to what I'm defining. So I can define this expected outcome using then. So yeah, that's the gist of writing Gherkin scenarios. You have a given, the initial stage, and then you have when, which is a trigger, an interaction that you are taking with that system. And you just want to make sure that when you do this condition, this when condition, this trigger, the system is going from this initial stage to this expected outcome stage, to the second stage. Maybe this was like a little confusing. I think with examples, it's going to be way better to understand. So I have brought an example here. This is an hypothetical example for writing a Gherkin scenario. In this case, what I'm saying here is given, and this is not my statement, I'm given I have arranged an array of dominoes evenly spaced in a straight line. That means I'm basically stacking those dominoes in a straight line, and I can just interact with them by knocking the first domino. So that's what I'm doing here on when. When I knock down the first domino, what should be my response? What should be my system's response to that? All dominoes should fall. That's my response. So in this case, what I'm saying is all dominoes should be knocked down. And that's one of the simplest examples I could think of for a Gherkin scenario writing. So you have this initial condition on given, you are interacting with it, and you have the final stage, this expected outcome. So, yep. And the idea of writing Gherkins is, again, we need to have this in a very readable language, and it should be very understandable. And this is what the requirement is going to be looking like. The scenario, I mean, this is what it's going to be looking like. So in theory, anyone reading this scenario should be able to understand this scenario. So even if there are people who are on the technical level and on the non-technical level, they should all be able to understand this. And we even have a concept on BDD, which is the three amigos example. So we could have the developer, we could have the tester, and we could have the product owner. They are all working together to define those scenarios. Oops, I stopped the presentation. Okay. Yeah, so all of the key players on the team can understand those scenarios. They can define those scenarios together, and they can work into developing these into the actual code. And you can also see that the should word here is highlighted. So this is, if you look at usual requirements, usual ears or encode requirements, we usually write requirements using the keyword shall. That's kind of enforcing that our requirement needs to be true. This Gherkin language tries to be a little more friendly, I would say, and encourage collaboration. So we use should, this keyword should here. Okay, so let's go to the actual scenarios. I'm going to show the scenarios that I have written for the chess game, and I hope let's take a look. Hope that's going to be a good example. Okay, hey Dan, do you think that's okay? Is it good to see there on the?
Yeah, looks good.
On the room. Okay, nice. Okay, so this is one of the scenarios that I have written, the very basic scenario. And in this case, I have a new keyword here, by the way. It's a and keyword. And that's basically just going to be adding more conditions into the given, into the when, or into the then. I can just basically add many steps into the given statement. I can add many steps into the when statement, and I can add multiple steps into this then statement. So in this case here, the very first scenario that I have, and by the way, this is the structure that I was talking about. I have this Pawn underscore basic dot feature. This is the file. Instead of this file, I have multiple scenarios. So I have two scenarios here, scenario 1 and scenario 2, and I can name them. This first scenario is highlighting pawn first movement, and the second scenario is pawn first movement to first square. And these are the steps. So each line here, instead of the scenario, is a step. Okay, so what am I trying to test here on the scenario? This very first scenario is talking about highlighting the movement. So what I have is, this is just an actor I have defined for the test. I'm going to explain later why I have added this, but it's usually not really, it's not a big thing here. So I'm just adding an actor. It's a player, and this player has an empty chessboard with dimensions 8 by 8. Okay, simple. We have an empty board, and the dimensions are known. They are 8 by 8. After I have this board created, I'm going to add a pawn into this position. So it's going to be the position 6-6. And the color of the pawn is going to be white. Okay, simple. I have an empty chessboard, and I'm adding a piece on this chessboard. I mean, adding a pawn to this chessboard. Okay, this is the precondition, this is the given. This is how my system looks when I'm first in testing it, the initial stage for my system. After that, I'm defining the when statement, and that's my interaction with the system. In this case, my interaction is when the player clicks on the pawn in position 6-6. So yeah, when the player clicks on the pawn, so that means the player is interacting, is clicking on the piece that was just added in the board. And what should happen in this case? I have defined the when statement. This is my interaction. So what should happen after I do this? I'm defining this on the then statement. So what I'm defining is the player should see the square, and this is the square, 6-6. It's the square the pawn is in. This square should be highlighted in yellow. So that means I'm just showing the square that the pawn is at, yellow, just to show that this piece is selected. And since this is the first movement of the pawn, we know that it is able to move 2 squares ahead. So I'm also saying that we should see the square 6. This is 1 row in front of it, actually 5. It's 1 row in front of the initial position for the pawn. The square 5-6 should be green, and the square 4-6 should also be green. So yeah, the two squares in front of the pawn. And let me just quickly show to you, I have created this chess board game, and I can just show to you how this looks like. So this is not the test itself, just to be clear. I'm just starting a new game here. So I have all the pieces here, and when I click to move a piece, let's say I'm going to click on this pawn here to move it, this square that the pawn is at is highlighted in yellow, and the squares ahead of it are highlighted in green. And another thing that I have also added here is when the piece can attack another piece, this square gets highlighted in red. So we have all of these 3 colors of highlight. So I just wanted to show that before I proceed with the testing. And yeah, so in this first case here, I'm just clicking on the pawn, and I'm checking if the highlights are happening as I expected. And the second scenario here, I'm actually trying to move the pawn. It's going to be similar to the first one. So I'm just adding a few more conditions on the given here. So I also have an empty chessboard. I am also adding the pawn on the same position, and it's also a white pawn. I'm also clicking on it, but if you see this now, I'm defining this click on the given. That means before even interacting with my system on the when statement, I have already clicked on it. So this is also one of the preconditions for my test. So I have clicked on the pawn position, and all these squares should be highlighted as I tested before. Okay, so in this case, in this test, I have already clicked on the pawn, and I already know the movements, the possible movements the pawn could take. And what I'm trying to do here is I'm clicking on the highlighted square 5-6. This is the square that is 1 row ahead of the pawn. So I'm trying to move it 1 square in front of it. And when I do that, what should happen? I'm saying that I should see the pawn move from the square. This is the initial square, from 6-6 to the square 5-6. So it's moving 1 step ahead. And I should also see that there are no highlights anymore. I have moved the pawn already, so there should not be any highlights. So the square 5-6, the square, I think it's supposed to be 6-6 here. I repeated this step. 5-6, 6-6, and 4-6 should not be highlighted anymore. And okay, this is all well and good. I hope that this was understandable. You probably were able to understand what I'm doing on this Gherkin scenario. But how can I run this? How can I make these tests run? Let me get back here. To run the Gherkin scenario, to run tests, that file by itself is not capable of doing anything. I'm just adding some plain text, and I'm just following the standard for Gherkin, and that by itself is not going to run tests. I'm going to be using some other tools that are developed around Gherkin, and there are many tools that we can use. For Python, we have this behave library that we can use for that, and it is going to be defining all of the commands that I can create. We're going to be using it to define functions. So basically, whenever we run a step into the test, it is going to be calling a function. And I have this set up here, how to set up this behave library. There are a few steps here. I think I'm probably going to skip this, and I'm just going to direct you to, we can link you the repository after this presentation is done, but I have on the README here, I have a lot of guides on how to do that, how to set up behave. So you can do that by checking this README. But once you do that, you can create a folder called steps. This is required. This is what behave defines that we need to do. You need to have this folder called steps, and inside of this folder called steps, you can create a script. In this case, we're using Python, so yeah, I have a Python script here. This is the script that I'm using for this file. So on this script, what I'm doing is I'm using those function decorators. This is a function decorator, and I'm basically saying that when I run my Gherkin file, whenever I see a step that is defined as given and has this statement here, it is going to be calling this function. So yeah, it's the exactly same statement. I'm saying that the player has an empty chessboard with dimensions 8 by 8. And this is exactly what I have here. What this is going to do is when I run the behave command, it is going to be reading those steps, looking for the step that is defined here. So this step, and it's going to be calling this function. So that means that running this step is the same thing as calling this function. And that's how we define, that's how we do the, let's say, translation to code from the Gherkin file. And I have this for all of the steps. And that means that I can run the Gherkin file, and I can show you how this looks like. To do that, I can just use this command, behave. If I just run behave by itself, it is going to be looking to all of my project here, looking for any .feature files and running all of them. So I can do that, but I can also select a specific file. And to do that, I can just give the file path. And this Gherkin file that I showed to you was in features on basic underscore movements dot feature, or actually movements, and the name is pawn underscore basic dot feature. And when I do that, it was very quick. I think you were not able to see, but it has run all of the scenarios. As you can see here, it's saying that I have run on a feature and it is passed. I have run 2 scenarios and they are passed, and I have run 17 steps and they are passed. I can actually add a little delay here to make it more visible. Let me do that. Okay, I'm running this again. So as you can see, I'm starting the test. I have an empty board and I have the dimensions. I have added a pawn here and I have clicked on the pawn. And now I'm checking if the highlights are happening as I expected. Okay, the first test was finished, the first scenario was finished, and I'm now doing the second scenario. I'm doing the same thing. I'm adding the pawn into this empty board. I'm clicking on it, and I see the highlights. And then, in this case, I'm clicking on the square ahead of the pawn, and as you can see, the pawn has moved to that square. And all of the steps are running here on the background, on these prompt here. So you can see all of the steps happening in real time. And this is kind of the simplest way of writing Gherkin scenarios. You can just write your scenario and use given when then, and you make those step definitions on a Python file. But there are a few ways of incrementing this Gherkin file. And I think we are like on the very top of the hour here, but I'm going to quickly show some other examples to you. So we can also use examples on the Gherkin scenario. And to do that, we are basically going to be defining variables inside of my scenario. How so? So basically, in this case here, I have another file, another feature file. And I also have another actor here. It's pawn player 2 this time. But in this case, I'm saying that I have an empty chessboard, exactly like the previous one. But now I'm saying that I'm adding a pawn in position. And I'm not saying the specific position just yet. I'm referring to those variables. I'm saying that I'm going to add these into a row and into a column. What is the value for those? I can define those values in the examples. And this is going to be a table. So in the examples table, I'm basically defining values for those variables. So in the first line here, I'm saying that row is a value 6, column is a value 6. And then I have two other variables, which is row move 1 and row move 2. And the row move 1 is 5, row move 2 is 4. So if I capture the whole scenario, basically it's the same thing as the one before. I'm starting on the position 6, 6, and I'm checking the square ahead of it, the square 5, 6, and the square two squares ahead of it, which is the square 4, 6. And I'm also checking for the highlights. And the cool thing about using variables is we can define many examples, many other lines here on the table. Each line is going to be run as a separate scenario. So I have the first one here, it's this as I showed, but I can also rerun the exact same scenario with different values. And I can just define as many lines as I want, as many scenarios as I want. And they are going to be just reusing this structure. And I think reusing is kind of a good word for defining Gherkin overall, because we can reuse a lot of things. We can really make this testing process be very scalable, because we are defining blocks, little steps, and those steps can be reused a lot of times in many different scenarios. Yep, and in this case, I have extra examples. Sorry, I have extra scenarios because I'm defining extra examples. And I also have the exact same scenario, the second one, with more examples here as well. So I can run this again, this second file. This is now called on movements underscore basic. And when I run this, so it's going to be the same thing for the first one, because it is going into the same positions, and it is all the same. So let's wait for this to be completed. Okay, there we go. The second scenario is also using the same frame, the same setup that I have, but it's now going to a different position. And that position is the one that I have defined on the second line, for examples. So it's actually starting on this square here. And in the third example, it is using this square here. So yeah, I can basically rerun the tests using different combination, different values. And yeah, that's all for the first scenario. And for the second scenario, I also have a few more examples. So yeah, in this case, I'm moving the pawn to the square ahead, to one square in front of it. Let's see. I think the delay is probably too long. Okay, so it has moved to one square ahead. And on the second scenario, I'm doing the same thing, but I'm now moving to the second square ahead of it. So let's see. Yeah, there you go. It's moving 2 squares ahead. So I can reuse the exact same scenario to test the 2 possible movements that I can take. And this is a really powerful tool. I can just scale this very well. I can just keep on adding more and more examples, more and more values possible, and this is going to be very scalable. Okay, let me, I'm going to quickly show you the final scenarios that I have. And those are kind of the most I defined here. And I have movements for the pawn, and also have movements for the knight here. And I'm going to remove the delay, and I'm going to run everything here. Or actually, maybe I'm going to add a very short delay, like this. Let me just stop this testing. This time I'm going to run all of the tests. So I'm going to just use behave. And if I just use behave, it's going to capture all the tests, all of the feature files that I have, and it's going to test everything. And when I do that, as you can see, there are a lot of things happening here. It's very, very fast. I'm not even sure if that's like visible or not. But yeah, all of the tests I run, and as you can see here, I have 5 features passed, 5 feature files that I have created, and all of them have passed. And there are 113 scenarios. There are 1,161 steps. So yeah, all of the features files have been tested, and everything is passed. Everything is approved. And yeah, that's basically how you use Gherkin for testing on Python. Let me go back to the presentation here. Again, I'm going to refer to the guide to make this setup, this behave setup, because we're kind of limited on time here. But yeah, you can create the step definitions, and that's going to be the Python file. And I just wanted to compare how BDD is compared with TDD. Let me show that to you as well. So again, I have those tests on Gherkin here, and they are meant to be like very readable, very simple to understand. Let me go back to this one, for example. They are supposed to be very readable. Any person reading these scenarios should be able to understand what's happening here. But when I'm going to do the same thing with the usual unit testing, this is one example for unit testing. I'm also testing a few other things here. So for example, I have a test to make sure that the size board size is correct. I'm also checking if I'm adding a piece in the position, and I'm checking, well, there are a lot of functions here. Each function is a test, and they are testing similar things to the ones that I showed before with the Gherkin files. But the thing is, to understand those tests, you need to be able to understand Python. So yeah, not everyone is going to be able to have this easy understanding of testing. And this is one of the issues. Like someone that is not technical is not going to be able to fully understand what's happening on these tests here. And by the way, I forgot to mention, but for testing in Python in general, we have this keyword here, a search. I'm not sure if you have heard of that before, but we can use that to do some testing. Basically, I'm going to pass a condition here, and it is going to be checking if that condition is true or not. If it is true, then that's okay. If it's not true, it is going to fail the test. I forgot to mention that before. But we also use the exact same thing on the steps definition. Let me open the file here. So for example, I have this step in which I'm saying that I should see this square highlighted in green. And to do that, I'm just checking if I'm using a search to check if this square, 4, 6, is in this list of highlighted moves. So this is usually how we define tests with Python, by using a search. And we can just do that on the steps definition file. And to finish the presentation, let me go back here. I just also wanted to say that even though I'm showing Python examples and I'm showing tests for Python, this is really like a broad concept that can be used basically anywhere. Something that I was doing recently is I created a Simulink model using MATLAB, and this was a Simulink model for the system that I was working on my job. And I was able to write Gherkin scenarios, and I was able to write steps definitions using Python. And by just using libraries, Python libraries, there is a library that is able to connect with Simulink. And I was able to run a Gherkin test using Python on MATLAB on Simulink. So we can use this approach of Gherkin and Python step definitions for basically anything. We can test anything. It doesn't really need to be strictly Python, a Python application. So we can test a lot of different things here. And as long as there's a library with Python, you can do that. And you can also do that for many other languages. For Python, we are going to be using the library behave to run the Gherkin scenarios, but there are also libraries for other languages as well. So again, this is kind of something that's very just a concept, and you can apply it on many scenarios, on many tools. These are just one of the possible approaches for that I want to show with you. And I think that's all that I had. So yeah, thanks everyone. Thanks for having me on this presentation. Thank you. Let me stop sharing.
Thanks so much, Robson. Does anyone have any questions?
Hey, Dan, I have one.
Okay, Go ahead.
So, Robson, I noticed that you use it Cartesian notation for the pawn movements in your script. So basically, typically chess players and chess books use algebraic notation. So for the BDD process, what is the best approach here? Should we prioritize the familiarity for those that are involved with the process, or be more code friendly?
I mean, we can take both approaches. Any approach should be working. Well, if we use the other approach that you talked about, we just need to do some working on converting that into actual coordinates into the board. So we could just let's say, I think the usual notation is having a letter for columns and a number for rows, right? Or something like that. We can just check and we can just check if, let's say, if it's column A, it should be row 0. If it's column B, it should be row 2, and so on. And we can just make this conversion. So there are many ways of writing this.
Okay, thank you.
And they can work. Yep, sure, you're welcome.
How different is writing the Gherkin statements from writing comments in the testing? Because I don't know if you can share again, but I'm just following. You write Gherkin given when then statements, and then there's a translation, right? Where you go from the Gherkin to something that actually executes.
Yeah, exactly.
So I'm trying to understand how that's better than just writing comments. Like someone has to be technically savvy to get the testing to run. So if that person just starts from pseudocode, why I'm trying to understand why not just write pseudocode and comments and then write the actual necessary testing after.
Yep. I guess there are a few positives and negatives to both approaches, some pros and cons to both approaches. But the main idea with having the Gherkin scenario itself is anyone can read this and anyone can understand this. And by just reading this scenario, we don't need to worry at all about how this is implemented. So one thing that I forgot to mention is, let's say I'm defining the Gherkin file that I have this step here. So I have an empty chessboard with dimensions 8 by 8. This step, on this test, it is completely agnostic of my application. It does not rely on my application at all. I can do this on any application. I might be using a web application. I might be using the Pygame application that I have done. I might be using any other approach. This is going to be true. This test here that you can see, this test is going to be true for any approach, any application. We just need to have some work into converting that into the actual code, which is the step definition that I showed before, into doing this processing. You might argue that it's simpler to just write a lot of testing functions, and in a way I think that is, but that's just looking at a software developer perspective. If we're looking to a team that has a lot of different people with a lot of technical, there are on different technical levels, having steps and just worrying about steps is way simpler than going directly to actual tests. I'm not sure if I answered your question, but there are a few points like that.
But right there, why wouldn't, so you have an at given statement, right? And then you have, that to me is just pseudocode, like a comment in the code. Why? I don't know.
Oh, I see. Like, there are also...
Yeah, I would write code. I would just write a bunch of statements of what I want to do, and they're comments, so they're English or pseudocode.
Yep.
And then I write the code after that. I mean, that's, I mean, it's kind of saying the same thing two different ways. I'm just trying to understand the magic.
Yeah. Yeah, I mean, I also agree with you. They are like different approaches, but they are kind of getting the same value in a way. I would argue that it is still more reliable doing on this Gherkin format because we are strictly enforcing the scenarios to be written in this readable format, and we also strictly forcing these statements to be defined as such. And this way, by having this given and then statement, we can actually do tests at a system level. We go a little out of just testing the individual functions. We go out of just testing small pieces of code. We go into actual testing of the system. Not sure if I'm actually being able to answer your question, but yeah, those are some of the points that we have.
Yeah, no, I guess I see. But yeah, thanks.
Okay, and another thing that I also forgot to show is, even though this looks like comments, this is really not a comment. There are some functionality to this. And one thing that I'm doing here as well is I have this script called general movements. And for this script, I'm defining the steps in a very reusable way. I'm using variables here. So for example, I'm defining this step, which is just this step here. I have an empty chessboard with dimensions. On this step, on the Gherkin file, I'm using dimensions 8 by 8. And on the step definition, I'm saying that I have a board, an empty chessboard with dimensions, length, and width. These are variables. I can take those variables into my function, and I can deal with those variables, whatever the value is. So I don't need to be strictly defining the numbers on the test or the numbers on the step definition. I can react to the values that are being added here. So when I run this step here, the value h and the value h are going to be added into those variables, and I can actually grab those. And what I'm doing here is, for example, converting this into an integer, both of them, and I'm creating a board with those dimensions, with those integers that I have just converted. And I can do a lot of that. I can also, let's say I'm adding a piece, and I just saying here, piece type. I don't need to specify which type it is. And instead of the function, I'm checking. Okay, so if it is a pawn, I'm going to be creating a pawn. If it is a rook, I'm going to be creating a rook. If it is a knight, I'm going to be creating a knight, and so on. And there is a lot of functionality that I can add into those decorators that we can use on Gherkin. Okay.
Any other questions? Yeah, that was cool, showing you're decorating the actual logic to your program and not just decorating the test functions, which is cool. Any other questions, anyone?
I just wonder, those scenarios, they're independent or has to be run sequentially, has to be one after another, or they are independent?
I don't know if you heard the start of the question, but I think the question was, do the test scenarios can they be run independently, or do they have to be run sequentially?
How the features, scenario, then steps inside scenario. Just try to render the concept. Each scenario, the multiple scenario inside the feature, are they independently or can run, without others, or has to be run sequentially from the first scenario to the last?
Okay, so each step is defined, is implemented separately. They are independent of the implementation, but when I'm using those steps in a scenario, they are done sequentially. What do I mean by that? If I'm using this structure here on this test, this step is always going to be run before this step. And I can do this sequential set of steps to achieve the system stage that I want. But I can just reuse steps in any other scenarios. So maybe there could be a scenario in which I'm doing a different order of steps. And to do that, I can just create another scenario using the other order of steps. And by doing that, I can, kind of reuse those pieces, those common steps, into different scenarios, and I can just rearrange them on any way I want. So yeah, in a scenario itself, everything is sequential. But when I define a step, I'm just defining a little block of function, and I can use that block in any scenario I want. Does that answer your question?
Yeah, that's very clear. The step is a kind of different rearrangement to make a different scenario. That makes really sense.
Okay, any other questions? All right, thanks so much, Robson. I thought that was a really good example using chess because it's so state-based and showing how you can, test a whole chess game using Gherkin. So thank you so much.